So welcome Salick Cogan from Fireblocks. He's a group manager on DeFi. He's going to talk to us about deciphering smart contract calls. I think you all are familiar with when you are signing the MetaMask and don't have any idea what goes on in there. So it's an important issue to learn and to solve. Give it up.
Okay. Hey everyone. I'll introduce myself. My name is Salick. I work for Fireblocks, obviously, in the Web3 group. And what we do is we have a few pillars. One is obviously a very strong footing in DeFi, in NFTs, GameFi, and staking. And what I want to do today is talk about a very interesting subject. In my background, before I joined Fireblocks, I worked at Wix, and Wix is a very B2C company, so I was very obsessed for the last few years with product and user experience. And what I hope to do in this talk is to try to mitigate the gap between something that is very technical from one hand, but needs to be very human readable on the other end, and we'll see why. So just a show of hands, how many developers we have here? Okay. And how many people from those developers ever made a smart contract call? Yay. And how many wrote a smart contract? Okay, cool. So the first part of the talk will be quite high level, and then we'll jump into something that is very technical. But I hope that we can still, everyone, understand what's going on. So deciphering, the dictionary definition of deciphering is basically taking a coded message and making it human readable. Okay? So to understand the problem, we're gonna see what creates the actual problem, then we see how we can solve it. So in the traditional web application flow, which is now called Web 2 as a swear word, Web 2 is bad, you have a client who's working on a browser, but it can also be a mobile device or actually a developer that is calling directly an API. A request goes out, reaches some kind of server which is private, right? It's usually owned by a company. It reaches the backend. The backend does something with the request, invokes some business logic, maybe takes some data, persists it to a database or some kind of data layer, and returns the result. So let's take, if you post on Twitter, right? Your post is a request that goes to Twitter servers. It contains the message that you wrote. They keep it somewhere, and then they are able to show it to other people. And everything that goes in this realm, in the backend, in the servers, is private. It's not accessible to anyone, and we can't really do anything with it. In the Web3 app flow, it's a bit different, right? So we have a browser, but also it can be from mobile or an API, and we issue a transaction. So if you go to, I don't know, some kind of DeFi application, you issue a transaction. The transaction needs to be signed by a wallet of some kind, and then the transaction, the signed transaction, is sent to the blockchain, which is public. It reaches a smart contract. The smart contract, again, like the backend function in Web 2, invokes some business logic. It can call other smart contracts. It can store data. It can emit events. It basically changes the state of the blockchain and returns a result. And what's different here is that everything that goes here is public. So if we're able to understand what actually happened, we can do a lot of interesting things. So there are more slides with words, but basically this is part of how a Web3 request looks like. You have the hash, the ID of the transaction, you have where it was sent from, you have the recipient, the to address, And then you have this mumble jumble of input, which is basically what we're doing or what we are trying to do. And obviously, this is not something we can work with, understand, and do anything with it. So if we are able to put some context into this request, we're able to do a lot of things. So one example is we can contextualize the request. I think Boris gave the example of the MetaMask. So this is a screenshot from what MetaMask shows when you do some kind of smart contract call. They actually say that they are not able to decode this transaction. And me, as the person who needs to sign this transaction now, is the problem, because I don't actually know what I'm doing, right? This is the source, by the way, to a lot of phishing attacks, because if you don't know what you're signing about, you can sign something that is malicious. The other use case is also security. So does anybody recognize? There's no way that anybody will, but yeah. So that's actually a quick swap, but yeah. 2 weeks ago, there was a hack, an interesting hack. Somebody hacked to GoDaddy by social engineering, and they got access to the DNS records of two DEXs, two decentralized exchanges. One is QuickSwap and the other is SpiritSwap. And so they redirected the domain to their own site. This site was an exact copy of the original decentralized exchanges, but they changed one small thing. They took the smart contract call and they changed the two parameter. This is what's marked here, and this two is the wallet address of the attacker. So everyone who came to these DEXs and swapped tokens during that time actually sent their tokens to the attacker's wallet. Now, if I'm using MetaMask or any other wallet that can tell me, hey, listen, the two address of the swap is not your wallet, then we have a big advantage. So this is another use case. And the third one is analytics, right? If I'm able to understand what's going on in the blockchain, not only the raw transaction, but actually what the data represents, I can do a lot of different analytics, right? I can go over and see how many people traded on a specific decentralized exchange. I can, if I look at liquidity pools, I can understand the impermanent loss. I can see the user retention, the fees that were paid, a lot of different things. This is a screenshot from DeFi Llama. It's a, those of you who don't know it, it's a website that shows you a lot of analytics on blockchains. Does anybody recognize this graph? USD. RIP. Actually, they're resurrecting now, but that's a different talk. Okay, so what I want to do for the rest of the talk, or at least most of it, is try to go over how we can actually take this raw transaction and make sense into it, okay? So the first part that we need is something that is called an ABI. What is an ABI? Basically, when you write a smart contract, what you do is you write it in some kind of high-level language like Solidity, and then you compile the code, right? The code is compiled to something that the EVM, the virtual machine of the Ethereum blockchain, can execute. But in order to interact with this compiled bytecode, we need some kind of translation, because I want to say, for example, swap this token to that token, and the code needs to understand what I'm asking, right? So there's a gap here that needs to be filled. And the way to fill it is something called ABI, which is Application Binary Interface. So when you write a smart contract, you compile it, you get the bytecode, you deploy it to the blockchain, and you also get the ABI. The ABI is the interface. How does it look? A bit technical, but we can do it. The top image is a very simple contract, right? It's called foo. and it has one function, which is called bar. It receives two parameters, okay? And if I generate the ABI for this contract, part of it will look like this. This is a simple JSON. It's human readable. So I can see that I have two inputs to this function. One is named X and the other Y. I have their types. So one is a number and the other one is a Boolean, yes or no, true or false. And I know that the function name is bar and it's a function, right? The type is function. So now that I have the ABI, I need to be able to tell the EVM that I want to call this specific function, because the contract can have many different functions, okay? So the way to do it is basically like a lot of things in blockchain. We use hashes, cryptographic hashes. So we basically take the function signature. So you saw before that the function name was bar, and it received two parameters. So I basically just take this string, this line of character, and I hash it. And once I get the hash, the result, I take the first 4 bytes, which is the 8 character, as every byte is 2 character of hexadecimal representation. And this tells the EVM which function I'm trying to call. Any questions? Okay. Niran, אתה איתנו? Okay. So we have the function, but we also need to encode the arguments, the parameters that this function receives, right? So let's see a few examples. If I take the value of 10, okay, the hexadecimal representation is going to be A, right? A is 10 in hexadecimal. And we pad it to be 32 bytes, okay? So you get 63 zeros before it. If I take an array, so a list of 2 different elements, I get A and B, again, padded with a lot of zeros. And the first example is, it's the same value, right? It's a list of 10 and 11, but it's encoded differently. And does anybody know why? Okay, I'll tell you. So the difference between the third one and the first is that we know beforehand that the value in the list has 2 elements, but in the first example, we don't know the length of the array, so it can be dynamic. So what we tell the EVM, basically, the first parameter is where this array is going to begin, where in the position of the input. Then we have, so the first 2 is actually, it's 20. It says start at byte 32. And then we have the second 2, which is how many elements I have in the array, in the list, and then the 2 elements, okay? So this is how we encode the arguments. And to summarize, if I want to call this contract, which is bar with x 42 and y true, I'm going to take the method, I'm going to take the 2 parameters which were encoded, I'm going to concatenate everything, and I'm going to send 68 bytes to this contract. So basically, if I look at this horrible string with a lot of 0, I actually can say that I'm calling function bar, and these are the values of the parameters. Okay, that's the gist of it. So in order to decode, we saw how we encode the smart contract call. In order to decode it, I need 2 things, right? I need the input data, and I have it in the transaction. And I need the ABI that tells me how functions are encoded. Okay, so let's try to do that pretty quickly on the transaction that we saw. So the first thing, when I'm looking at transaction, I need to get the ABI, right? how do I get the ABI? I look at the recipient, the to address. This is the address of the smart contract. And in some magical way, I'm going to get the ABI. Now that I have the ABI, I look at the input, right? So I take the first 4 bytes of the input, and from that I need to somehow understand which function I'm calling. So if I take a look at the ABI and I take all the functions that are listed in it and hash all of their signature, I'm going to find the 4 bytes that represent the specific function that I'm calling. So in this case, this function is calling swap exact tokens for tokens. By the way, this already tells me that it's probably something that has to do with swap. And I know the 6 parameters that it receives. Okay? So now I can move on and try to decode the parameters. So I look at the next 32 bytes after the first 4 bytes, and I know that I'm looking at the parameter which is called amount in. We'll talk about it a bit later. And I can say that it's 5 billion, right? And then I can move to the second parameter and say that it's 32 billion or 33 almost. And I can do it on all the function arguments. So I have this list of addresses which will try to understand what they mean. I have the to address, right? It's very important. And I have something called deadline. Does anybody know what the deadline is? What it represents? Yeah, so deadline is basically until when this request is valid. So if somebody tries to send this request in 2 years, it won't be valid anymore. So to summarize what I did here, I managed to look at the request, decode it, and now I know much more, right? I know which function is being called, I know the parameters, but I can do actually more, okay? What can I do? Does anybody have an idea? So I can actually look at the addresses and enrich the data to give me more context. So these addresses are, the first address is USDT, which is a stable coin. The second address is the AVAX token, which is the base token of the Avalanche blockchain. And the third one, does anybody recognize the logo? USD, yeah.
You can also normalize the amounts.
Yeah, for sure. We'll see it in a sec. So I can actually go one step further and tell a story, right? I can say, hey, what's actually happening here is that someone is taking 5,000 USDT and is trying to get at least 32,900 USD because it's no longer pegged to $1. And the conversion is trying to be done via another token, which is the AVAX token, which is, we're at a much better step, right? Much better stage. If I have a wallet, I can show this to the person signing the transaction. He can decide if he wants to do it. If I'm building some kind of firewall for DeFi security or any other product, I can maybe alert him that the address that he's sending is not the address that he expects. Maybe the conversion rate is not what he's expecting to receive. A lot of different things. So this is only the request. Actually, it doesn't mean that this is what is going to happen eventually, right? So we can do the same process. I'll jump over it, but we can actually look at every time you call a smart contract, it emits events. And these events are written as logs in the blockchain, and you can actually read them and see what actually happened and make sense of it. So we can look at the first log, and I'll save you the decoding, but it actually means that there was a swap between USDT and AVAX, or wrapped AVAX. this amount of USDT came in and this amount of AVAX came out. And then there was a swap between AVAX and UST. This amount of AVAX came in and this amount of UST came out. So actually, not only show what was requested, I can actually show the actual result. And now I can do a lot of different things, right? I can compare requests to results. I can calculate slippage. I can do it for all the swaps that ever happened. If I'm building an aggregator, right, that you just request a swap and it gives you the best place to do the swap, I can look at historical information and maybe derive something from it. So I can do a lot of different things. Yeah, that's true. So right. So the comment that Nir said is that there's something that we assumed here, right? We assumed that we know what swap does. We assume that we understand the parameters, and we assumed a lot of stuff, and that's correct. Basically, in order to understand smart contracts, you'll also have to analyze them to some extent. The advantage that we have today is that if you look at DEXs today, most DEXs, 250, are forked out of Uniswap, the Uniswap contract. So you can, if you actually learn Uniswap, you can immediately understand 250 DEXs, right? So that's an advantage, but yes, you're right. There is some kind of heuristics that you need to define in order to be able to tell this exact story. But I believe that as you know, as this ecosystem matures, it will be more and more easy to do. Like, I don't know, computer vision today, you don't need to, you look at the picture and you understand this is a human and this is a car and so on. I believe it will be very easy to do in this field as well. So, a bit of a technical question, but we saw that functions are, we take only the first 4 bytes and not the entire hash. And the question is, does anybody know why? Sorry? But why don't we take the entire hash? Space, which is expensive, gas, okay? So there's a cool, it's not a trick, but it's a nice consideration that Ethereum builders did. So if you look at cold data that arrives to the blockchain, if it's a byte that has 0 in it, it will cost 4 gas. If it's non-zero byte, it will cost 68 gas. And because hashes are pseudo-random, right? So what this means is basically that if you take a signature, every byte has 0.3%, 1 to 255 chance to be 0, right? Because there's only 1 0 in up to 255. So if you take only the first 4 bytes, which is enough, you pay much less gas, which is great. And by the way, if you look at L2s like Optimism and Arbitrum, they actually use 1 byte because they say a contract can only have 256 functions. It's not, it's enough. So they do a lot of different optimizations to that. Another challenge here is that I just said that we get the ABI of the contract, right? But we don't always have the ABI. If you go to a contract in Etherscan or any block explorer, you won't always get the ABI, right? It's not, you don't have to upload it. A lot of the contracts do it, but you don't have to. And then we're in a problem, right? Because I don't really know how to decode this, this function and make sense of it. And there's something really nice that is called the 4-byte directory. It's like yellow pages of different function calls in across all blockchains, basically. And if you give it the 4-byte, you get the signature, right? You don't really need the ABI. So even though I don't have the ABI, I can still make sense to some extent of what this function does. But what you can see here, that we don't have the name of the arguments. We only have their type. So this means that we have some context, but to an extent. Okay? And in Fireblocks, what we do, part of what we do is basically deal with this problem, right? Because we want to, first of all, provide great security. So we need to be able to mitigate to our users what they're actually going to do. We're providing the kind of firewall. So we need the firewall to understand what the requests are doing. And we also want to contextualize and give analytics and insights to customers. So we also need this part. And that's it, I think. I hope it wasn't too technical, maybe a bit. Any questions? Yeah. Great question. So the question was, what about proxy contracts? To those of you who don't know, a proxy contract is, okay, let's start from the beginning. What is the problem that proxy contracts want to solve? The blockchain is immutable, right? That's one of the great properties of blockchain. What you put there can never be reversed. So if I'm writing a smart contract and it has a bug, I can't fix the bug, right? Because I can't override the smart contract. So what proxy contracts are basically contracts that just pass the call to the actual contract that holds the implementation. So in that case, if you want to, you fix the bug or you want to change the implementation, the proxy contract where you actually send the request remains the same, but you proxy it to a different implementation. And the problem is that the ABI of the proxy contract is not the ABI of the actual implementation. And the solution to that, to some extent, is when I look at a contract, at an address, I can say that it's a proxy. And because I can say, the way to say that it's a proxy is it usually has the property of implementation. That's the standard. And implementation is the address. So I can go and take the ABI of the implementation, and that gives me the context of the actual contract that I'm calling. Yeah. No, no. What's done is done. The way that proxy calls is they store. So you give permission only to some other contract, which is the admin contract, to change, to set the implementation. So only someone, the admins of the company or whoever created the contract can change the implementation address, and then they just replace the contract that it goes to. Yeah. That's a great question. It happens. So if you look at the 4-byte directory, you could sometimes, I think they override, so they just give you the last one they saw or something like that, but it is possible. It is possible. I didn't do the actual calculation mathematically, but it's a problem. I think it's not very significant. Like it's at the edges. Another good question. So what we saw today is EVM, right? Everything that is EVM compatible. If you look at blockchains like Terra, for example, in Terra, this problem doesn't exist in this manner because everything is JSON. So if you look at a request in Terra, you can actually see a JSON, which is much more human readable, and you can infer from that. There are other blockchains that basically take the concept of ABI, they rename the parameters, and they say we invented something else, but it's the same concept. So Algorand, for example, they use ABI-based interfaces, but if you look at the ABI itself, it's written a bit differently, but it's exactly the same. Okay, thank you very much.